Bukan, gue soalnya sekarang lagi ini kan, rumah kan direnov nih, gue sekarang lagi balik ke rumah, jadi bajunya masih berantakan, jadi gue cuma ngambil yang ada aja.
Ya, masih oke lah. Nah, sekarang...
Ada suara Bayu masuk.
Suaranya yang dari sebelah masuk, ya.
Yes.
Ini kita udah streaming? Udah live?
Sudah live.
Live.
Waduh, oke.
Your show starts now, Jo.
Not yet. By the way, Angel, are we ready? We are going to start the session in about 2 minutes.
Okay. So, Professor Lin, have you tried a new device?
Okay.
Professor Lin?
Yes.
Have we tried all the device and all the materials we are going to have?
Yeah, I think so. I'm ready.
Okay. Okay, then NTPU is ready.
Okay.
Miss Nurul, my second slide, you need to click because I use animation on that second slide.
So many students already in waiting room.
Yeah, because the normal class start at 8:30. So they
they're already there.
Okay.
Yes.
Yeah. Okay. So do we still have to display the QR code at the end of the session, Miss Nurul, since you are going to copy the link only? This one?
Yeah, we can show this and then we can also give them the link in case the QR code doesn't work.
Okay.
Okay, yeah?
Yeah.
It's good?
Okay, 9 o'clock is ready.
Yeah. Okay.
Okay. Now I let everyone enter the room, okay?
Yes, please.
Admit all.
Miss Joanna? Miss Joanna? You just mute yourself.
Yeah, sorry. Okay.
Can you provide me the link of the YouTube stream?
Oh, Miss Nurul, could you help on
that?
One?
You can copy from this one. Yeah. Copy streaming link.
Yeah, or you can click on the live on YouTube.
Miss Lee here, Angel.
This one.
Yeah, I see that. Thank you.
Okay.
Okay, everybody.
Can we start now?
Sure.
Everyone stand by. Okay. So good morning, students. Everyone is here now?
Yes, I guess.
Okay, yeah. Good morning, students. Good morning, lecturers. I'm Johanna from the Overseas Program, Business International. I'm so happy to see you all this morning to host this international guest lecture, Artificial Intelligence and Applications to Computer Vision, proudly presented by Computer Science of Binus University International in collaboration with National Taipei University, Taiwan. So welcome on board. This morning, we are so lucky to have Professor Dalton Lin, Distinguished Professor at National Taipei University, and Ms. Angel Kuo, a project manager from NTPU as well. So we are going to learn from Prof. Lin to hear his perspective about AI and applications to computer vision. So don't waste this chance to gain knowledge and get first-hand experience from Prof. Lin. But before we go further, I need to share our housekeeping rules as usual. Yeah, first, mute your audio, okay? And then instead, I encourage you to set your video on. So everyone who hasn't set the video on, please now turn on your camera so Prof. Lin may see your faces. Okay, thank you. And then next, after the lecture, we will provide Q&A session. So during this session, you may drop your questions on the chat box, or if you wish to speak directly to Prof. Lin, you may raise your hand. Be active. And then after that, this is the best parts, I know, quiz. Therefore, don't forget to take notes during the flight. Okay, and at the end of the session, I will display a QR code to claim your SAT points and IE points. That's our housekeeping rules for this morning session. Now let's move to the next one. I would like to invite the head of computer science program, Mr. Raymond Bahana, to deliver a welcome speech. Mr. Bahana, the screen is yours.
Okay, thank you. Hello all students, all participants. Yeah, welcome everybody to this event. First of all, I would like to thank Professor Dalton Lin. Yeah, thank you want to share your knowledge with our students in this event. Also, thank you everybody that joined this event, the student from Binus University. I also a student from National Taipei, I think, the university. Yeah, hope all of you will get more knowledge about AI after this event. Yeah, don't hesitate, guys, to ask any question in the Q&A session. Yeah, everything that maybe you're not clear or you want to ask, yeah, we have the professor here, so you can ask many questions. Okay. Also, I would like to thank everybody that helped us to have this event, especially Miss Angel Ko, project manager from National Taipei University. Also, Miss Yaya and Miss Johanna from overseas program in Binus. Thank you so much for your help. So this event we can help. I hope in the future we can also help many other event, not only maybe with webinar in Zoom. Maybe in the future we can visit each other and we'll have an event on site. Also maybe we will work together for research or something like that in the future. Again, thank you everybody and enjoy this session. Thank you all. Back to Joanna.
Thank you, Pak Bahana. Yeah, we are so looking forward to meet Prof. Lin and Miss Angel Ko in person in the future. Now, before we jump to the course session, some of you might not know yet about National Taipei University. So I therefore would like to invite Miss Angel Ko to introduce National Taipei University to us. Miss Angel Ko, the time is yours.
Hi. Good morning, professors and students. My name is Angel. I work as the coordinator of international relations at Office of International Affairs of National Taipei University, the NTPU. I'm very happy to meet you by this very special event, and let me briefly introduce my university. Located in New Taipei City, the National Taipei University is a public institution founded in 1949. It is well recognized as one of the best universities in Taiwan. After different stages of development, the university is still growing in size, and it consists today of 7 colleges. The total number of our students is about 10,000, and out of which 450 are international students. That's approximately 4%. And each year we send over 175 exchange students to our partners all over the world, and we host more than 100 from our partner universities. Today, we are very happy and very honored to have invited Professor Lin to give us a lecture on AI and the computer vision. Professor Lin is actually the teacher of Department of Computer Science and Information Engineering, which is one unit of the College of Electrical Engineering. We'll call that a College of EE. And the College of EE is established in 2007. And it was founded in association with the High Technology Science Parks located in northern Taiwan. In addition to the Department of Computer Science and and Information Engineering. It also consists Department of Communication Engineering and Department of Electrical Engineering. The College EE has been recognized as the leader and innovator in the research and education. And today, the college contains one program that is fully instructed in English, which is the PhD courses in electrical engineering and computer science. Not only is fully instructed in English, but also it's a very professional program, focuses on networking and multimedia development and other fields like digital and analog and mixed signal IC design, computer engineering, system engineering, wireless communications, multimedia signal processing, and RFIC design, and so on. The college EE has been accredited by the IEET, and if you are interested, I think you can get on the website and check some further information, but also I will strongly recommend you to hand over your application and have a short exchange program at National Taipei University. I believe a short-term exchange will inspire you when you plan for your future life. And now let us take a look at the video at the introduction of NTPU. And after the video, we'll have another video introducing the international students' life in our campus in the perspective of an Indonesian student who is currently enrolled as a 3-year student at the International Program of Urban Governance. And now let's have the video played.
Founded in 1949, the former Taiwan Provincial College of Public Administration, the Provincial Law and Business School, and the Law and Business College of National Zhongxin University were reorganized into National Taipei University in February of 2000. For now, in addition to the Taipei campus, NTPU is headquartered in Sansha with nearly 10,000 students. With a foundation laid by teachers and students over the years, National Taipei University has continued to develop and steadily thrive. Started as a law and business school, the College of Law has been established for more than 60 years and has nurtured numerous outstanding talents. Whether in judicial practice, law research, or legal counseling for other public and private sectors, the alumni of the College of Law have played important roles. The Center for Comparative Law Documentation has collected and collated Chinese and foreign legal documents and proactively compiled important international code of laws. The College of Business emphasizes cross-disciplinary teaching and research and encourages teachers to develop innovative teaching materials. It also inspires students to conduct cross-field learning. It has designed innovation, creativity, and entrepreneurship courses to break traditional barriers between different departments and colleges. In 2016, the College of Business earned the AACSB certification. It will continue achieving its vision towards global excellence in higher education, maintaining a leading position in social influence, and providing the best business education and research institute in the Asia-Pacific area. The College of Public Affairs is the first professional college in Taiwan that aims to cultivate talents in management of public affairs. It has proactively engaged in studies on theories and practices related to public affairs and assisted government agencies or non-governmental organizations in improving their public affairs management skills. Accepting challenges in the public environment, the College of Public Affairs will also continue to enhance student professionalism and ethics. as well as their humanities accomplishments and international perspectives, so that they become citizens with a core competence in public affairs and human solicitude. In addition to cultivating social science talents for the benefit of society in traditional disciplines such as economics, sociology, and so on, the College of Social Sciences has also proactively conducted cross-disciplinary cooperation and constantly carried out various new research topics, thus playing a significant role in promoting social development in the country. In addition to academic research and teaching, the College of Social Sciences puts strong emphasis on services and practices and is working hard on social practice projects currently, which aim to connect the university with communities, encourage teachers and students to apply what they have learned to social practice, and to be a responsible member of the local regional community. Besides the traditional academic knowledge and humanistic literacy, the modernity and applicability of different fields have also been emphasized by the College of Humanities, which departs from the Haishan area and has been closely integrated with the localized cultures. On the basis of humanistic literacy, the College of Humanities has dedicated itself to encouraging its students as well as to establishing multifaceted and practical competencies to advance knowledge and capabilities interdisciplinarily, and to turn out outstanding professionals at different stages through international, cross-university, and inter-college and departmental cooperation and development. Founded in 2007, the College of Electrical Engineering and Computer Science EECS combined Department of Computer Science and Information Engineering, Communication Engineering, and Electrical Engineering into a college. The emergence of the EECS College represents a completely different idea for the campus that has been traditionally famous for social science education. The EECS College, dedicated to fostering talents in high-tech research and development, establishes a more solid foundation for development of a comprehensive university. Adjacent to the Industrial Park and the Science Park in northern Taiwan, the EECS College also has the advantage of being an important link connecting industries, teachers, and students. Being the seventh and the newest college of NTPU, the International College of Sustainability Innovations, ICSI, was established in August 2019. It now provides 2 fully English-taught master degree programs for international students, the Master Program of Business Administration and Finance, and the International Program on Urban Governance, IPUG. By providing quality education and a friendly learning environment for students coming from all over the world, ICSI aims to enhance NTPU's competitive advantages and contribute to the world with our abundant teaching and research capacity. Faced with rapid changes around the globe and fierce competition among talents, and with its core strengths in the Law and Business School, the School of Public Affairs, and the School of Social Sciences, National Taipei University will continue to pursue innovation, research, and development, and foster talents for modern times. Besides teaching, research, and the formal curriculum, the Innovation and Entrepreneurship Center was established to offer counseling to students and encourage them to foster innovative thinking and entrepreneurial soft power so that they can put their learning into practice. The Career Development section also continues to strengthen the employment competitiveness of students and the intensity of their career development. In the era of globalization, National Taipei University is proactively connecting with worldwide universities and research institutes by signing memorandums of cooperation so as to accumulate plenty of energy and competitiveness via international exchanges. A great city should have a great university. As the first university in the country that aims to develop the campus based on the idea of a college town, National Taipei University has not forgotten its responsibility as a community member. In academic research, teaching, and action services, National Taipei University has been cooperating with local communities. Now, National Taipei University is not only a good environment for teachers and students to conduct studies and research, but also a good open space for community residents to enjoy leisure time. pursuing the truth and serving the people are united as our spirit. We believe pursuing perfection holds great value in today's world. It is a guarantee of social stability and the significance of National Taipei University.
Now let us meet Mr. Mohammed L. Ghaufri, the IPUG student.
It's been my dream since I was a kid to study abroad. So when my university recommended me to take an opportunity provided by Ministry of Education of Taiwan, I took it because this is a rare opportunity. Taiwan is one of the friendliest countries I know, particularly to Muslim community. That's why I am here. Also, I'm quite interested in Chinese culture since I was a kid. I can learn an authentic Chinese culture as well as the language, which is I wouldn't find it at other places. Not to mention that Taiwan has provided a lot of scholarships to international students. This university has wonderful facilities to the international students. The environment itself, which is quite convenient for students to study, where I can find it in any universities in Taiwan so far. I found that this university has a very unique environment as well as the program, because this university has a new program, so-called International Program on Urban Governance, which is quite interested or attracted me to enroll here. My plan is to stay for a while here to gain more experiences in terms of entrepreneurship. Also, given the fact that Taiwan is currently focusing on facilitating Muslim community needs, I saw this a great opportunity for me so that I can establish my own business that has something to do with the halal stuff. Also, I'd like to make a good relationship between Taiwan and Indonesia become more and more solid in the future. I would highly recommend my friends and whoever I know. For my friends out there, welcome to Taiwan, where you can find beyond the heart of Asia here.
Thanks for watching the videos. Thank you very much. I hope we can host you very soon in our campus. Now let's get back to Joanna and Professor Bahana. Thank you.
Yeah, thank you, Angel. Well, I couldn't be happier to develop further on the exchange students cooperation so that our computer science students may experience NTPU on site. Looking forward to Angel. Let's talk about this later. Okay, thank you again for the introduction. Now, without further ado, my pleasure to hand this screen over to Ms. Nurul, lecturer at AI class of computer science program. So Ms. Nurul will conduct as a moderator. Okay, Ms. Nurul, are you ready? Over to you.
Yes. Thank you, Ms. Jo. All right. Good morning, everyone. Good morning, students. This is our special session, yeah. So after these QA sessions, don't forget we will have a quiz as I promised to you last time. So please be ready and pay attention to this guest lecture sessions, and you may also prepare your questions, yeah, so that you can get as much takeaways as possible from the sessions. Okay, before we start, it's a great pleasure for me to introduce our honored guest lecturer today, Professor Dalton Lin. Professor Lin received the bachelor degree in control engineering from National Daw-Tung University, Hsinchu, Taiwan in 1985, and the master and PhD degree in electrical engineering from the University of Maryland at College Park, USA in 1990 and 1994. He is currently the Distinguished Professor of National Taipei University, Taiwan. He has been with the National Taipei University since 2005, where he became a tenured Professor of Computer Science and Information Engineering in 2009. He is also a senior member of IEEE. He has been a regular contributor to the literature in computer vision and image processing. His research interests include image processing, computer vision, pattern recognition, and intelligent surveillance. Okay, everyone, please join me in welcoming Prof. Lin. Prof. Lin?
Yes.
Now the screen is yours.
Yeah, thank you, Dr. Nuna's introduction. Let me share my screen first. Do you guys see my screen?
Yes, Prof.
Okay. All right. Good morning, ladies and gentlemen. It is my great honor to join this virtual conference with the faculties and the students both in at the Venus University and the NTPU. Before I talk, I would like to thank Joanna and Andrew and also the other working staff for your great job to make this conference possible. And I also thank Professor Pahana's opening speech. So in this talk, I'm gonna talk about the artificial intelligence and the application to the computer vision. I believe you already know my education background, and my research interest is that I have more than 25 years of the working experience on image processing, pattern recognition, computer vision, artificial intelligence, neural networks, and also deep learning. I have done some work about medical image recognition. So today I'm gonna talk about some introduction of the artificial intelligence, computer vision, and also I will share with you some of my research results, especially the result from academic and industrial collaboration projects. Then finally, the conclusion remarks will be made. So, let me ask you a question. Have you heard about AI? Maybe you can put your answer in the chat box. I wonder if we can open the chat box so that the student can share their opinion, right?
Yes, Prof. The chat box is active.
Thank you. So have you ever heard about the AI? I believe so. I believe your answer is of course. Okay. So with the advances in the field of artificial intelligence and specifically the branch of AI known as machine learning and the deep learning technologies have attracted increasing research interest over the last decade. So this is because the inherent capability of overcoming the drawback of traditional method. So AI is becoming mainstream in the software development. One of the most disrupted AI technologies is Alphago. As you may remember, all right, as you may remember, Alphago, which is a program that use machine to master Go, developed by which is developed by the Google's DeepMind. The Alphago has defeated the world championship in 2016. All right. So recently, in 2020, as you know, the COVID-19 pandemic year, a major scientific advance of AI system developed by DeepMind is AlphaFold 2. AlphaFold 2, which has been recognized as a breakthrough solution to the protein structure prediction problem. So the AlphaFold 2 demonstrates the potential of AI as a tool to serve as a platform for better understanding of specific diseases and to advance the development of specific areas such as drug design and environmental sustainability. In 2018, one of the birthplace of artificial intelligence, MIT, has announced a $1 billion US plan to reshape its academic program to create a new college for AI. So it was the largest financial investment in AI by any US academic institution. The MIT Strassman College of Computing was effective in January 2020. All right. This college combined AI, machine learning, and the data science with other academic disciplines, and will be a focused home for computer science and artificial intelligence education and research. The new building will be finished in 2023. So as you can see, all the academic and the industries are following the AI trend. So what is AI? What is AI? This is the definition from the website. Artificial intelligence refers to the simulation of human intelligence in machine. That are programmed to think like human and mimic other actions. The term has also been applied to any machines that exhibit traits and associate with a human mind, such as learning and problem solving. Now, computer vision is defined as a field of study that seek the development technology to help computer see and understand the content of digital image, such as photograph and the video. So recently, artificial intelligence has been widely applied to computer vision because it can drive a meaningful information from digital image, video, and other visual input. The demand of AI applications is more likely to increase as AI adopting grows and companies can prove to consumers that their AI technology can enrich their life. The self-driving car, I believe you already know that. The self-driving car is a typical example of AI applications for the computer vision technology. Next, I will show you a demonstration of the driver monitoring system called EyeSight, all right, which is developed by Sepia, is a company. This technology uses computer vision and artificial intelligence to create safer and better in-car experiences for the self-driving car. So next, you will see a video you will see several technologies such as face recognition, speech recognition, gesture recognition, and so on and so forth. Let me just share with you the video first. All right.
Hello, Tom. Here are some nearby businesses that may interest you. Rush Sports Club has been added to your locations. Autonomous driving activated. Approaching urban area. Resume manual driving mode. Song added to your playlist. Attention on road. Time for a coffee stop.
Okay, so actually, the eyesight, as you just see the video, the eyesight technology has been deployed to many luxury cars. So it is not a dream, it is happening right now, especially for the self-driving car. So for the AI, one of the key terms is the machine learning. So what is machine learning? The key concept of the machine learning is that it can build a model. It can build a model based on a simple data. Let me just put on my pointer. All right, the key concept of the machine learning is that it has some kind of algorithm. You all are computer science students, so you know the terminology algorithm, which it can build a model based on sample data. The sample data is known as the training data. All right, so training data is a keyword. Now next, for you to gain better understanding of machine learning, I will show you a few pictures and let you try to differentiate if the subject, whether she is a Netherlander or Dutch, or whether she is a German. Okay, now every student, do you think this girl is a German or Netherlander? If you think she's a German, then put G on your chat box. Otherwise, if you think she is a Netherlander, maybe you can put N on your chat box. How about this girl? Is she a German or Netherlander? Maybe you are not quite sure about that. So next, I will provide you a few samples with the correct answer. This is a German. Please observe. This is also a German. All right. This is a German. This is a German. And then this picture shows a girl who is a Netherlander. So this is also a Netherlander. Again, Netherlander and a Netherlander. So I have provided you a few training samples with correct answer. Now, previously you may confused or you are not sure whether this is a German or Netherlander, right? Can you make a better decision now? Yes, I think you can. Yes, she is a German. How about she? Yes, she is a Netherlander. So what we have done is the process of machine learning. So again, let's visit the key sentence again. So the machine learning algorithm build a model based on sample data, known as the training data, for you to make any decision or prediction. Okay, so now you may have better understanding what is the machine learning. Actually, machine learning is a subset of artificial intelligence. Although today we always talk about artificial intelligence, but actually artificial intelligence covers a lot of different materials in a very wide range of the in the computer science. It can trace back to 1950s. Up to 1980s, machine learning start to rise up. So as I just said, machine learning is a subset of the AI, especially in machine learning. In this decade, the deep learning breakthroughs drive AI boom. So again, deep learning is a subset of the machine learning. So deep learning is a function, is an AI of is an AI function that mimic the workings of human brain in processing data for use in detecting objects, recognition, speech, translation, languages, and making decisions. The main differences between the machine learning and the deep learning is that due to the way of the data is presented to the system. So as you can see in these slides, the upper part is the process of the machine learning. So for machine learning, in addition to the training data, as you have experienced, when you try to observe the several pictures I provided, you may have some kind of measurement. For example, you will see, for example, if we want to do the face recognition, all right, maybe you may observe what's the differences, what's the distance between the eyes, or the distance between the eyes and the mouth, all right? And whether she or he is wearing some kind of clothes or the hairstyle, something like that. So before we learn the samples, we also are doing observation. So for the machine learning, you have to define some kind of pre-process procedure to measure all the features, all the characteristics of your sample. Then come up some kind of classification algorithm, for example, SVM, for random forest, and so on and so forth, to make the decision based on the probability distribution of all the features. Suppose the feature is the F1, F2, and so on and so forth. However, for the deep learning, we don't have explicit method to extract all the features. We don't measure the distance. We don't observe any features from your input sample. We just input the whole images to neural networks. If you have ever heard about the neural networks, which is the mathematical model, emulate how the signal transmitted in our neural system. So all the features, instead of finding specific feature as the machine learning does, the neural network find the features by itself based on the layer by layer structure of the neural networks. Then come up with the decision also by the learning process. So right now, so-called AI is actually, this successful part is actually deep learning and the machine learning. So talk about the applications. Right now, almost the best applications from AI has been deployed to computer vision, speech recognition, and also the natural language processing. Today, I'm gonna focus on the application of computer vision. So next, I will share with you some of my research results. All the results are typical academic and industrial collaboration projects. Most of them cover the, for example, the surveillance, vehicle detection, and face detection, and so on. So the first application is about the vehicle detection. In this work, we implemented a deep learning-based neural network model to accurately identify, track, and count vehicles for the street intersection. Especially for the street intersection surveillance, both for general single directional camera, as you can see right now. So, and also on the right-hand side is the fisheye camera. The overall camera, the overall vehicle counting accuracy is up to 95%. As you can see from the video, on the left, you can see not only detecting the vehicle, it also identify whether it is a large vehicle, as you can see plotted in red box, or the small vehicle, which is plotted in a blue box. And the motorcycle is plotted in yellow box, and the pedestrian, which is plotted in the green box. On the right-hand side, also do the similar things, but for fisheye camera, so you can see several directions, and you can count the in and out for the traffic flow control. And the next, I will share you with the result of the license plate recognition. This is founded by a company called Orbit. This example is from Singapore. We have a site in one of the schools in Singapore. So you can see the picture. This is the camera view of the vehicle. All the vehicle, this is a raining day, as you can see, the raindrop. All right, again, the raindrop. And also nighttime. All right, dark, even dark. So this application, we achieve over 99% of the accuracy for license plate recognition. For the next application is about the vehicle segmentation and the tracking. As you can see, in this work, we propose a fully automated deep learning based system for the traffic analysis. It can recognize all the real-time motion events and justify all the abnormal traffic flow and do the prediction. As you can see on the left screen, we have very high quality vehicle segmentation. On the right-hand side is the tracking, is the result of tracking. After you do the segmentation, of all the subject on the left, you can continue to do the tracking As you can see, the green trajectory is the tracking trajectory, and the number on the top is the vehicle ID. So for a stable system, the vehicle ID should, the same vehicle ID should always follow the same vehicle without any changes. Otherwise, the tracking will be incorrect. So we achieve almost 97% of prediction accuracy for 1 second ahead the position. Next, I will show you the continuous work for previous results. After we have a tracked right-hand side, on the right-hand side video is the result of the tracking. We have done the tracking, then we want to do the vehicle behavior prediction. What is the behavior? Behavior means we want to predict 1 second ahead or 2 seconds ahead and even 3 seconds ahead whether the vehicle is driving ahead, driving forward, or maybe the vehicle is going to turn left or turn right, or pull to the roadside to stop, or something like that. So this is so-called behavior prediction. Let me play the video again. Sorry, let me come back. Let me go back to previous slides. Okay, it's playing again. So what we have done is that after we do, as you can see, we have a box here, right? So we have we develop a novel 3D bounding box prediction construction for the vehicle on the video. Then project the 3D bounding box location to the left-hand side, which is the Google Map satellite view. So we project all the motion, all the moving vehicle on the moving object on the right-hand side to the left-hand side. So as you can see, the red line is the prediction. The green line again is the history of the object, and the red line is the prediction in 1 second, 2 seconds. As you can see, there are 3 dots ahead. Let me play again. All right. So you can predict whether this vehicle, for example, this one is going straight forward. As you can see, this is kind of random because it is the pedestrian. Because the motion for pedestrian is very slow, and usually it fool around. So the prediction result maybe not so reliable. But for the vehicle, it is very significantly stable. So that based on the prediction, you can predict whether any two cars will have an accident. For example, again, the green line is the history of the history trajectory of this vehicle. And the green line again is the history trajectory of this vehicle, and the red line is the behavior prediction. So when you do the behavior prediction for both cars, you found that maybe in 2 seconds or 1 second, two predictions will be meet together. That means there will be an accident. So in this way, we can have a better monitor. We can have a better monitor on the Google Map view, which car is driving safely. Which cars will have accident? So that you may suppose we have IoT, then we can send a message to the vehicle for warning ahead. Finally, this is an interesting application to enhance the add-on value of the ceramic pottery product, as you can see on the screen. We have introduced the augmented reality technology and combined the AI recognition method to create an app for their product. So as you can see, this is a result of the app. All right. So when you take the picture, actually this is a video. When you aiming at your object, your app will appear some interesting subjects. For example, the birds. The birds show up. The birds flies up in your screen. So in this way, as you can see from the demonstration, you can increase the interaction or bring some funny games together with your product. This is another example. This is a video recorded from in our experiment from the mobile phone. So you can see this is augmented reality. The red box means the stability of our recognition. No matter how you turn your gaze, it always can follow the object. Same for the right-hand side. Let me see if I can click on the video on the right-hand side. Yes, this is another vase. Okay. Some flower bloom is blooming from your application. So again, no matter how you turn your camera, the recognition should be stable. This is another example for a mug. So as you can see, the bird flies up. Actually, this is a special species in Taiwan, which is called a bluebird. On the right-hand side, let me see if I can turn on the video. Right. So again, this is another application, another scenario for our app. All right. So in order to make a real demonstration, let me turn off my screen, and I want to share with you my mobile phone. So please hold on a second. Please hold on a second, and let me terminate my share. Hold on a second. Can you see my screen?
Yes, Prof.
Okay. Can you hear my voice?
Yes, clear.
So this is my mobile phone. All right. Let me turn on the voice. I cannot turn on my voice. Anyway, all right. So this is, can you hear my voice?
Yes.
Can you?
Yes, yes.
Can you hear my voice?
Yes, Prof.
Okay, good. Do you hear the music?
No.
Well, anyway, actually there's a music. Anyway, as you can see, anyway, I just want to show you the 3D animations. For example, I'm holding a mug, right? This is my mug. So when I turn on the app, all right, you can see something interesting. Let me change to another mug. For example, this one. All right, see? This is another mug.
We cannot see anything, Prof.
You cannot see anything?
No.
How about now?
Not yet.
Can you see now?
Yes, we can see.
Okay, good. Let me turn on again. So this is another mug. This is another mug. All right, something like that. So let me go back to my slides. Okay, let me go to my slides again. Okay. So okay. So here's my conclusion. Let me just turn off my mobile phone because it has echo. Okay, now it's better. So artificial intelligence research is ongoing. The artificial intelligence and the deep learning convolutional network has led to considerable advancement in object detection, classification, in computer vision study, and applications, as you has just observed, which I shared with you. In this talk, I have demonstrated some of our state-of-the-art research works and their application. Further exploration of AI technologies are required to enhance and improve our researches and impact the future. This concludes my talk. Thank you very much.
Thank you for the talk, Professor Lin. Very mind-blowing. So I saw that your current research, yeah, that's very interesting, especially with the AR thing. That's new. I just see it now. So I never saw that before. So that's very, yeah, interesting. Okay, students or everyone, if you want to drop any questions, please raise your hand and I will call your name and unmute yourself. Okay. Anyone want to ask? We also welcome from other lecturer too, yeah, to ask questions.
By the way, do you see my background? This is
Yes.
our college building. So all the faculties and the students are very welcome to visit us in the future if you have a chance.
Sure, sure. Okay, anyone? How to raise hand? Okay, in the reaction, you can click raise hand. Okay, Aksha, maybe you can unmute yourself.
Oh, very well. Is this working?
Yes, working.
Okay, so I have a technical question regarding the slide before this conclusion. Mostly like regarding the image, the augmented reality images, like what form of deep or machine learning did you apply to make those images appear in 3D as they do like in the videos?
You mean the architecture of our deep learning network?
I mean, which deep learning method did you use to enable those images to become 3D?
Okay. Actually, there are two parts. Let me, hold on a second. I am in my office, so the school. Okay, this is a signal for the school, from the school. Anyway, there are two parts for this work. First, it is the motion from structure. We have to do motion from structure to construct the 3D information of your subject.
Ooh.
And the second is the object recognition. For the object recognition, we applied autoencoder. We applied unsupervised learning network autoencoder to enhance the precision of the object recognition. Because traditionally, the key point and the descriptors are plays the important role for the object matching. This is typical object matching or image matching problem. You can imagine that suppose you have several bays or several marks as shown on the slide on the PPT. So in your database, your mobile phone also have several image which you want to match. You already have some kind of image as I shown on the right hand side. So for the application time, when you take a big picture of your object, then your system, your app will match all the sample images in your mobile phone. So they find the most the most similar one. All right. So for the image matching, the key point and the descriptor are the important feature. So we instead of manually or using conventional methods to find the key point, we applied the autoencoder to extract the key point and features for the matching application.
All right, thank you, sir.
So autoencoder is main architecture we have applied.
All right, I see. Thank you, sir.
Thank you.
Okay, thank you. Thank you, Axel, for the questions. And any other questions regarding the general AI or computer vision? Okay, Jason, you can unmute yourself.
Good morning, Sir Dalton.
Yes.
I have a question. Do you think AI and its derivatives can find use in fitness and workout? If so, how? Thank you.
Repeat your question again. I don't get you. Do I think what?
Do you think AI and its derivatives can find use in fitness and workout? If so, how?
You mean
like sport, exercise?
Oh, sports.
Yeah, getting healthy.
You mean
Getting healthy.
Can AI apply to sports?
Yes.
Yes.
Or exercise?
Yes, Prof.
Of course. Actually, this is quite interesting question. I think for the training, the training is a good application. For example, if you play basketball, right? How you make a shot? You have a good, if you have a good pose, or if you have a good maybe you have good motion route, then you may have a better chance to have a shot, right? So usually people the researchers put the motion sensor on the athletes. So when they make any motion, we can measure that. So AI can detect whether this is a good, whether this is correct or not, to based on the motion sensor signal. And for the this is for training. Training is AI can be applied to sports training, and also for maybe for the broadcasting, right? When you try to see the all the trajectory of all the players, right? You can analyze whether those player are making a correct route or making a correct gesture, something like that. So this is good. This is an application so far. You can see applied by AI. That's what I have seen.
Okay. How about that, Jason?
Great. Thank you.
Thank you. Okay, I see somebody else raising his hand. Hank, please, you can unmute yourself.
Hi, Professor. Good morning.
Good morning.
And your speech is amazing, and I'm really excited. I have one question. In the future, the self-driving car and application of the AI technique will be a growing trend for sure. And this makes me thinking that if, say, a car accident happened, who should be responsible for this accident? Is it the AI or the driver?
This is also a good question. This is beyond my expertise. This is belonging to the role maker expertise. I believe there should be some kind of very strict definition for the development of the AI, especially for human life applications such as self-driving car. So actually, your question reflects that computer technology, you may not have always 100% correct decision based on the current technology. Even human being can make mistakes, right? So who will take the responsibility? It is a debating issue. So every country is going to find a good regulation, either for the AI maker, AI software maker, or the vehicle maker. So I believe well, I cannot have good answer right now. So, but I believe in the future, every country should define a better rule for good regulation for this issue. Thank you.
Thank you so much.
Thank you, Professor Lin, for the answers. And then now we move to the next question from Jerry. Please unmute. Yeah.
Hello. I'm sorry. This is like a long question, but do you think AI will be able to improve so much that like it will be able to create something on its own? For example, in arts, music, or literature, currently they're using algorithms that are like repeating the things that are put into them. But do you think they will be able to someday create something by themselves?
Yes, I think so, but for a specific domain. For example, at the very beginning in this talk, I mentioned about the Alphago, right? So Alphago is developed in 2016 and 2017. After that, DeepMind, the Google DeepMind, continue to develop Alphago. So the next version is Alphago 0, and again, the newer version is called Alpha 0. What they did is that the new version of Alphago, which is called Alpha 0 or Alphago 0, play the games with itself. So the machine compete with itself. For example, 1,000 times or 10,000 times. Then the machine compete with itself, then it can learn more and get the good prediction very increase by a very short in a very short time. So this is an example of the AI learned by itself or create by itself. But don't worry about AI can substitute all the works we are doing now, because currently all the AI applications are still in a specific domain. For example, the Alphago can only play the Go game. It cannot drive the car. The self-driving car program can only drive the car, cannot play the Go game. So AI development should be focused on a specific domain, not in the just you see from the movie, the scientific film. It is kind of that the robot can do everything. So it is still far away. I think maybe 50 years ago you will see that. I cannot see that. This is my answer.
Okay, thank you for the answers. Okay, how about Jerry? Do you have any follow-up questions?
No, thank you.
Okay, thank you. Okay, now Jaco, please unmute yourself.
Hello, sir.
Yes.
I have a question regarding the augmented reality. Up to what point do you think augmented reality will have its advancement? Like, do you think it will reach the point where smart glasses are available to the public?
It's already available. You mean, what's your key?
Because last time I noticed that Google and Apple both plan to have it for public, but then Google take it back, the glasses, because it distract people a lot in the in streets, so they don't have it in public anymore.
Oh, you mean the Google Glass?
Yeah, and other, like, I think Apple was planning to have it also. Or like, what advancement will it has to reach its maximum potential?
Okay, you mean the potential of the augmented reality?
Yes, sir.
I think for example, for this application I shown on the PPT, which is a kind of consumer electronics application. The consumer electronics application using augmented reality is everywhere now. But for the, for example, the Google Glass, I think because of the hardware, the Google Glass is still not so comfortable when you wear the Google Glass, because of the projection technology. But as I know, many companies are working on that. So I would expect in the very near future, you will see people will wear a kind of Google Glass, maybe not from Google, some other company, and he can interact. He can interactively see through and get some information from his or her glasses. It is. I think it is possible. This is what my opinion.
All right, sir. Thank you for that.
All right, thank you. So yeah, we're looking forward to it. Yeah, Prof. Okay, next questions, Eric.
Hello. Hello, Sir Dalton. I have a question about your augmented reality application. I'm curious on how do you generate the proper background sound for the 3D effects? Can you elaborate more about that, sir?
You mean the background?
The background, the sound, the 3D sound when you use the augmented reality.
The music.
Yeah, the music.
Or the music? Do you mean how
yes,
do
sir.
I enhance the music or what? Or how do
you generate the proper music for the pictures in the program?
Okay, it's by program, because you design the scenario. For example, in this case, when you see something like a flower, then you will show flower. So it has been set up in your program. So the 3D animation and the music is designed by the artist. It's already once you can set up a program said once you recognize the bird, then it will play the specific music, something like that. So it's not a problem at all. Do I answer your question?
Oh, yes, sir. Yes, sir. Thank you.
It's a kind of rule-based.
Yeah. Okay, Eric?
Yes, miss. Yes, sir.
All
Thank
right.
you.
Okay, so I guess one or two more questions, last questions, before we close this Q&A. Anyone? Okay, if you don't have any question, maybe I can ask one question, Prof. So since you already did this research like 20 years ago, so when you maybe at that time there is no deep learning racing, right? So how you feel with the changing of the world like nowadays? How's your research back then, and when you compare it with now, what is some challenging issue, or how do you feel about that?
Okay, this is a very, very good question. When I first worked on the neural networks, actually, I would say that the methodology are all the same. Deep learning versus neural networks versus machine learning. The fundamental methodologies are the same. They are all from probability distribution. All right. All the classification decision is based on the clustering from statistics. All right. So the math is very important. I would say that to all the students. Mathematics in the computer science, for example, I'm not sure if in your courses you have say something like probability and the statistics, for example, like linear algebra. Those are very basic and very important math courses. So the differences between the current deep learning and 20 years ago, the neural networks, is that now the structure is bigger and bigger, becoming bigger and bigger, larger and larger. Before, when I was a PhD student, I only worked on neural networks for example, 3 layers or 4 layers, and we did the experiment for example, the digit recognition. All right, the sampling data is only say 100 digits per 100 samples per digit. For example, if you want to recognize the digit 0, 1 up to 9, previously, because of the computer, the limitation of your computer power and also the memory, you can do limit of work. But right now, the computer speed is, I would say, 100 times faster than before. And the memory is thousands times larger, available, and cheaper than before. So the current deep learning, why it is called deep? Because it has, you can build up 100 layers of neural networks to do the classification or prediction. And right now, the hardware is affordable. Furthermore, many people, thanks to the open source, thanks to the open source platform, you can easily get an open source from the outside. Then you can start to build up your own network very easily. Before, we need to do the hard coding line by line. If you are a computer science student, you may know what I'm saying. It is hard work. So right now, students can build and learn the deep learning very quickly. So, but I still recommend that just not you don't just download the open source and run the program. You need to also think about what is the basic theory, the fundamental subjects of this field, so that later you can even contribute your own source code, your open source code to the publics. So this is what I feel about the differences between the current status and maybe 20 years before.
Okay.
If I answer your question.
Sure. Thank you, Professor Lin. Okay, so I guess we run out of time. It's 10:35 almost, yeah. So I should wrap up this QA sessions. So guys, don't worry, yeah. AI won't replace human, as Professor Lin said. Yeah. We need to focus on developing AI to ease our life, yeah, not to afraid of the development of AI itself. Yeah,
I agree.
I think that's it for this guest lecture. I can give it back to our MC, Miss Johanna.
Yes, thank you, Miss Nurul, and thank you, Prof. Lin. What a knowledge for me as a normal human being. I don't know exactly about AI. This is my first time listening to AI. Thank you so much, Prof. Lin. Yeah, so before we allow Prof. Lin and Angel to leave this room, we are going to take a photo. So please, students, turn on your camera. Yeah, while waiting students to turn on their camera, I would like to clarify one thing, that actually BINUS and NTPU have established a student exchange agreement. So for you students, if you would like to join NTPU for a short program, you may consult with your head of program for your study plan, and you may contact overseas program for further information. Okay, now let's take a pic together. How many we have? Yeah, hold on a second.
Okay, video guys.
Okay, open your camera, please, student.
Yeah. We have 2 pages. Yeah. Okay. We are still waiting for some students. Come on. Students, turn on your camera. Okay, Jagonia. Yeah, we are now on the first page. Okay, I'm going to take a pic. And 1, 2, and 3. Yes, another one, second page. Hold on. And 1, 2, and 3. Yes, thank you so much, students. Now we are going to allow Prof. Lin and Angel to leave this meeting room. But students, you have to stay in this room because we are going to have quiz.
Yay, quiz time.
Only BINUS student, yeah?
Yeah,
only
my student
please
only.
Remain in this Zoom room because we are going to have a quiz. And again, thank you so much, Prof. Lin and Angel.
Thank you.
We hope to see you.
Thank you, Prof. Lin. Thank you, Angel.
Good luck on your quiz. Have a nice day.
Take care.
Take care.
I think NTPU students can also leave the chat room.
Oh, we have NTPU students. Thank you so much.
Yes,
I see
NTPU
some.
students, would you please turn on your camera? For all the NTPU students, please. Thank you. Yes, we have more than 10 students joining in.
I just can recognize Lee here.
Yeah.
Please also send me the picture.
No problem.
Yeah, okay. Problem. Yes, sure.
Right.
Okay.
Thank you.
Thank you so much. Have a good day, Prof. Lin.
Thank you.
Have a good day.
Have a nice day. Thank you, Professor Lin.